Hi there. Welcome to Pure versus Applied Chemistry. In these notes, we'll be learning about the difference between pure chemistry and applied chemistry. Pure chemistry is when you are in the pursuit of information just because. You're just messing around and trying to see how things work. This leads to accidental discoveries. So you figure out how things work or find some information out that may be useful to people, but it was by accident. And also, if you are doing chemistry and you're exploring things, just trying to find out how things work without expecting any practical use for the knowledge. So if you are trying to figure out the structure of a material, but you're not expecting to do anything with that information, you just are curious what the structure is like, then that would be considered doing pure chemistry. Applied chemistry, on the other hand, is when you are researching for a practical purpose. You have a goal, you're trying to find something or see how something works on purpose or for a specific reason. And so these discoveries, due to performing applied chemistry, leads to on-purpose discoveries. You were looking for something specific, you're going to apply your knowledge to something specific, hence the word applied chemistry. So let's read through this example and then figure out if this was pure or applied science. In the late 1940s, Dr. Lawrence Craven observed that gum containing aspirin, which was used to relieve pain after the removal of tonsils, caused excessive bleeding in children. He hypothesized that aspirin prevented the blood from clotting. He then began to prescribe aspirin to prevent heart attacks. In 1985, the FDA approved aspirin for patients who had suffered a heart attack. In 1996, the FDA proposed using aspirin during a suspected heart attack. In 1997, an advisory committee recommended daily low dose of aspirin for people at high risk of a heart attack. So was the discovery in the 1940s found by pure or applied science? Go ahead and pause the video and think about that for a second. So in the late 1940s, Dr. Craven was observing that gum containing aspirin caused excessive bleeding. He wasn't looking for that on purpose. He wasn't looking for a cure or a preventative for heart attacks. He wasn't doing that on purpose. He found this discovery and made this connection by accident. So we would call this pure chemistry. Here are some more examples. Developing a cancer treatment, would you consider this pure or applied? This would be applied because you are finding something specific and applying your research to something specific, which would be cancer treatments. Determining a temperature required to make something melt, pure or applied chemistry. This would be pure chemistry because you're just figuring out temperature required to make something melt, but you're not applying this to anything specific or useful. You're just trying to figure out how something works for kind of random knowledge. Figuring out the general structure of materials such as cotton or plastic, pure or applied. Again, this would be pure because you are just looking for the structure. You don't have a purpose for the structure. You're not researching anything specific or practical. It's just for kind of for fun to figure out how things work. So this would be pure chemistry. Developing a large-scale method for producing a product. This would be applied. You're researching and you're developing something specific and so you are applying your research to something, so this is applied. Explaining why density changes in a solid, liquid, and gas. This would be pure chemistry. You aren't applying the knowledge to anything specific or useful. You're just explaining why things work and not applying it to anything useful. So this is pure chemistry.